TV Happy Math Hour, our weekly interactive and math reviews for Math 1314 and Math 1324. Today, Math 1314 will be covering synthetic division and complex numbers, while Math 1324 will be solving exponential and logarithmic equations. The link to Math 1324 will be posted shortly. Our presentators today will be Ms. Yvette Chuca, Mr. Ruben Carrizales, and Mr. Albert Isasi. This session will be recorded so that you may come back to it later if you need to, and so others that may have missed out on today's events will be able to come back and watch it. So now, at this time, please mute your mics for best sound experience. Otherwise, the feedback could interfere with the information we'll be sharing today. Without further ado, here is our presenters today.
Hello, everyone. Happy Friday. So today we're going to be discussing problems from Chapter 2, and our focus will be on synthetic division and complex numbers. Okay, so before we get into synthetic division, let's talk about one of our most important terms here in Chapter 2, which is what is a zero. And so if I have this equation, it can be factored into these three factors. And this point here that is circled, that is what we call a zero. And it occurs at x equals 2. And since it's a zero, we know that x minus 2 is going to be a factor. Okay, and we'll get into that a little bit later. So one of the things that we want to do, we'll give you an example of long division. And so for long division, if you have a number, let's say 25, and you want to divide this number by 2, then if we just consider how we divide these, 2 goes into 2 one time. And then from here, we normally in our minds, we would multiply 2 times 1 is 2. And then what do? We subtract. So 2 minus 2 is 0. And then lastly, we bring our next number, we bring it down. Then we start the same process. 5 divided by 2 goes in 2 times. 2 times 2 is 4. And then again, we subtract. And then we're left with 1. And so 1 is our remainder. And so today we're going to do something similar, but with polynomials. And these are just some of the things that we have to consider. One of the first things you want to do is arrange the terms of the dividend and divisor in descending powers. And then we're going to divide the first term in the dividend by the first term in the divisor, similar to what we did right here. We took the first term and we divided by the first number here. That's what number 2 means. Then we're going to multiply, and then we're going to subtract. And so what we did with the numbers, it works the same way. Then we bring down the number and so on. So with an example, you'll be able to see it a little bit more clear. So here we have this polynomial, and we want to divide by 4x minus 3. So the first thing we want to do is rewrite it to look more familiar to division. And so here we have our polynomial, and we're dividing by 4x minus 3. And so what we're going to do is consider that first term, and then we want to make sure that they're in descending powers. So we have a 3, a 2, a 1, and then the constant. So we take the first term, 20x cubed, and we divide it by the first term of our divisor, 4x. And so if we divide this, we get 5x squared. So that's going to be our first number here. And then what do? We multiply this 5x squared times each of these terms. So now we end up with 5x squared times 4x gives us 20x cubed. And 5x squared times negative 3 would be negative 15x squared. So our next step is to subtract. So notice my subtraction symbols here. But I'm going to go ahead and put everything in parentheses because we're subtracting the entire result in here. And so basically what happens here is we distribute that negative, and we end up with negative 20x cubed. Negative is positive 15x squared. And so if we subtract now, we're going to have 20x cubed minus 20x cubed is 0. And negative 35x squared plus 15x squared is negative 20x squared. And now we're ready to bring our next term down. So we end up with 23x here. And so now we're going to repeat the process. So now we're going to take that first term. Let me go back really quick. So we're going to take this term here, negative 20x squared, and divide it by the 4x. And so that's going to give us negative 5x. And so negative 5x times 4x, negative 20x squared, negative 5x times negative 3, positive 15x. However, we're subtracting this entire thing. So I'm going to have my subtraction here. And then we're going to distribute our negative in there. So negative negative would be positive 20x squared. Negative times 15x would be a negative 15x. And now we bring our last number down. So we end up with 23x minus 15x is 8x minus 6. So now we take that term 8x divided by the 4x, and that goes in twice. So 4x times 2 would be 8x, and negative 3 times 2 is negative 6. However, if we subtract, we're going to end up changing these. So we would have a negative 8x, and then negative negative would be positive. Okay, so in reality, at each step, what we're doing is changing our signs because of that subtraction. So now let's, once we subtract here, we end up with a remainder of 0. So let's look at these items a little bit closer. So 0 is your remainder. Then you have your quotient, which is your answer. And your divisor is what we divided by. And everything inside of here is called the dividend. So to write your answer, we're going to write it in this form, the quotient plus remainder divided by the divisor. So this polynomial, when divided by 4x minus 3, we end up with 5x squared minus 5x plus 2, which is our quotient, plus our remainder of 0 divided by our divisor. Okay, so this is one way to divide polynomials, but what we want to focus on today is synthetic division, which is essentially a shortcut for long division. However, for synthetic division, we want to have our divisor to be in this form here, x minus c. So let's look at some examples here. In general, these are the steps, right? So you still want to arrange these from decreasing powers. And then we're going to identify each coefficient for each of these terms. So for x cubed, my coefficient is a, so I'm going to write it here. For x squared, my coefficient is b, so I'm going to write it here. Then my coefficient for x is c, and then we have d. If you're missing any of these terms, then we would use a 0 to replace it. Then we need to identify what our k is going to be. K is just going to be this number c here. Our next step is going to be to bring the first coefficient down. So we get a, and then k times a, we're going to multiply. So we get k, so we get ka, and then we're going to add it to the b. So we end up with b plus ka, and then we repeat the process. Okay, so that we can get these numbers here. So let's try it with an example. The last number is going to be your remainder, and then the terms before the remainder are used to find our quotient. Okay, so let's say we wanted to divide x squared plus 5x plus 6 divided by x minus 1. First, we want to identify k. So in this example, k is going to be 1. The next thing is to list the coefficients. So x squared has a 1, x has a 5, and 6 is our constant. Next, we're going to bring down the first number, so we get 1, and now we're going to multiply it times this 1. So 1 times 1 is going to be 1, and then we just place it below the second number. So now we're going to add 5 plus 1 is 6, and then we repeat the same process. So now we're going to multiply 1 times 6, and then we write our answer here. Then we add 6 plus 6 is 12. So this means that 12 is our remainder. And then we're going to use 1 and 6 to help us find our quotient. Okay, so that was our divisor. Now our quotient is always going to be 1 degree less than the dividend. So in our dividend, we had a power of 2, an x squared. So for this first one, we're going to start with x. So we go 1 less. So if you have a 2, now we just have x. So this 1 would be the coefficient for x. And then we have plus 6 plus our remainder, which is 12, divided by our divisor, which is x minus 1. Okay, so we have a few of these examples so that we can practice. So here we have another one. So first we identify k. K is 8. And now we're going to get the coefficients. So the coefficients would be 4, 36, 36, and negative 32. We bring down the 4. Then we multiply 8 times 4 is 32. Now we're going to add 36 plus 32, 68. We repeat the process. 8 times 68, 544, plus 36, 580. Then we're going to multiply 4,640 plus negative 32 is 4,608. And so now we can write our answer. So we're going to identify our remainder, 4608. Our divisor is x minus 8. And now for our quotient, since our dividend had a power of 3, when we write our quotient, we're going to go 1 less power. So this 4 would be the coefficient for x squared. Again, notice that we had x cubed, so we go 1 less, 4x squared, plus 68x, plus 580, plus our remainder, 4608, divided by our divisor, x minus 8. Any questions? Again, we have a couple of more. So now we have this polynomial divided by x plus 7. Notice that it's a little bit different. The ones we've done, we had x minus a number, but now we're going to have x plus a number. So we still need to identify what k is. And so this x plus 7, I can rewrite it as x minus negative 7. And so our k will be negative 7. Okay. So now our coefficients, we would have 3, 21, negative 6, and negative 42. Then we're going to bring the 3 down and multiply it times negative 7. So we get negative 21. Plus 21 would give us a 0. And then 0 times negative 7 is 0. Add to the negative 6. So we get negative 6 times negative 7, 42. And if we add, we get a remainder of 0. And then as Mr. Carizales put a happy face, as you're doing these, if you get a remainder of 0, that's going to be awesome because it's going to help us to find the rest of the zeros, which we'll talk about a little bit later. So now let's write our answer. So our degree was cubed. Now we're going to go 1 less. So we have 3x squared. 0 would be for x, 0 times x, minus 6 plus our remainder of 0 divided by x plus 7. We don't have to keep the 0 times x, so we can write our answer as 3x squared minus 6. 0 divided by x plus 7 is just 0. Okay, one more. It's a little bit different. So our k is going to be 5. But notice what happened here. We have x cubed minus 3x squared, and there's no x. So we want to make sure that we use 0 for that x. And then we have our plus 6. So our k is going to be 5. and then our coefficients would be 1 for x cubed, -3 for x squared, 0 for x, and 6 for our constant. Bring down the 1. 1 times 5 is 5, plus -3 is 2. 5 times 2 is 10, plus 0 is 10, times 5 is 50, plus 6, 56. So if we write our answer, we're going to go 1 degree less. So we started with cubes, so this would be x squared plus 2x plus 10 plus our remainder divided by x minus 5. Okay, so that is how we find, that is how we divide a polynomial by another. And so now we're going to look at this remainder theorem. It says if a polynomial f of x is divided by x minus k, then the remainder is r equals f of k. So what this is saying is if we take our k and plug it in for all the x's, whatever the result is, that will be our remainder. But I'll have an example here so we can really see how it works. So it says use the remainder theorem and synthetic division to find each function value. So first we're going to do f of 1. And so first let's talk about synthetic division. So given f of 1, we know that x is equal to 1. So this number in the parentheses, that is your x is equal to that number. To find the k, if I bring 1 to the left side, then I have x minus 1. So my k is going to be 1. So in other words, whatever the number is in the parentheses, that's going to be your k. Then we write down our coefficients. So we have 2. There's no x squared, -7, and then positive 2. So we're going to bring down the 2. Times 1 is 2, plus 0 is 2. Times 1 is 2, plus -7, -5. Times 1, -5. So we end up with -3. Now the remainder theorem, so let me go back here. So the remainder is -3, but it's not a 0 because we didn't get remainder of 0. Now in the remainder theorem, all we have to do is plug in our 1 into every x and simplify. So here we would get 2 times 1 cubed minus 7 times 1 plus 2. And if we simplify, we end up with -3. So if the question was, what is the remainder? Then you have two options. You can use synthetic division or you can use the remainder theorem. Okay, so let's try -2. For -2, that's my k. If I do synthetic division, I end up with a 0, which is awesome. Again, we'll tell you why it's awesome in a little bit. But this tells us that since we got a 0 here, then -2, that's going to be your 0. So what exactly does that mean? Well, if you were to graph this, that is telling us that you're at this point right here, x equals -2, we have a 0. That means that the graph is going to either touch and cross, or it's either going to touch and turn, or it's going to cross. Okay. So our goal is going to be to find these zeros here. If we use the remainder theorem and plug in -2, then we can see that we also get 0. So essentially, this is just showing you that you can use synthetic division or the remainder theorem to figure out if something is a 0 or not. Okay, so how does it help us solve equations? Here's an example. Find the zeros for the given function, given that x is equal to -2 is a 0. So here, since they tell me that x equals -2 is a 0, then I'm going to go ahead and use synthetic division. So I write my -2. And then I get my coefficients. So I have a 2. There's no x squared, so that's 0, -7, and positive 2. Since they tell me it's a 0, then I better have remainder of 0. So we go down, bring the 2 down, times -2 is -4, plus 0, -4, times -2 is positive 8, plus a -7, we get 1, times -2 is -2, plus 2 is 0. So it does give us a 0. If you get a different number, then you know that we did something wrong over here. So now this is how it helps us. Now what we want to do is take our quotient. And so if we had x cubed, we're going to start with x squared. So we're going to end up with 2x squared minus 4x plus 1. So now what do we notice about our quotient? It's actually quadratic. And so we have different ways to solve a quadratic equation. We can try to factor. We can use the square root property if it's an option, or we can use the quadratic formula. So at this point, when we use synthetic division, we're trying to break this cubic into something that we can solve easier using quadratic methods. So now to find the rest of the zeros, we can try to factor. And this factors as 2x minus 1 times 2x minus 1. So we get x equals a half and x equals a half. So my zeros for this problem are x equals -2. That's what we got from synthetic division, or that's what was given as well. And then the other two zeros were a half and a half. The degree was 3. That means that I should have 3 zeros, 1, 2, and 3. It just happens that one of them repeats, and that's okay. All right, so I should have put another example, but anyway, so the idea is that we can use synthetic division to help us find these zeros. Okay, so let's go on. Here it says we're going to talk a little bit about complex numbers. So expanded system of numbers to solve problems with no real solutions. So if we had this, x squared plus 1 equals 0, and we're trying to solve for x, we would subtract the 1, and then we would take the square root, and then we would have x is equal to square root of -1, which is not a real solution. So if you were to graph this, the plus 1 tells us that the parent function is shifting upward 1 unit. And so in our graph, you're not going to have your graph is not going to intersect this x-axis. So if you have a negative inside of the square root, that means that your graph is not intersecting the x-axis. So it could either look like this one or like this one. Okay, so this is not the graph for this equation, by the way. All right, so what we want to do is, so these mathematicians, they ran into some walls here because they had a negative in here. So they still wanted to continue their work. And so what they did is they did a whole number system, a whole brand new number system, which is called the complex numbers. And then they created an imaginary unit, which they called I. And so basically they defined I as the square root of -1, where I squared is equal to -1. So this definitions right here, we're going to use to solve different problems. So complex numbers in standard form is a plus bi. When you're doing your assignments, it's going to ask you for the standard form. So you want it to look in this way, where a is the real part and bi is your imaginary part. Okay, and so here's the definition. So a is a real part, bi is your imaginary part. And we're going to, in order to have a number system, all the operations, they have to work just like our regular numbers. And so we're going to add, subtract, and multiply complex numbers. So if you're given two complex numbers, a plus bi and c plus di, and you want to find the sum, then what we're doing is we're adding the real parts, a plus c, and then the imaginary parts, bi plus di, which we can write as b plus d with your imaginary number. And then for subtraction, same idea, a minus c, and then we have b minus di. Now, some of you might want to memorize this, but it's not necessary because you can just treat them like similar terms. And so I'm going to show you both ways. So here we want to add 3 plus I plus 6 plus 5i. So by definition, it's going to be 3 plus 6 and 1 plus 5. And so we simplify, we get 9 plus 6i. But the other way is just combining like terms. So you have 3 plus I plus 6 plus 5i. So the like terms are 3 and 6, so that's 9. And then you have an I and 5i, so that's going to be 6i. If we subtract and we use the definition, then we have 3 minus 2 and -1 minus -1. So we get 1 plus 0i, which is equal to 1. Now in the computer, it might ask you to enter it as 0i, or it might take the 1 actually. If you want to combine like terms, then we have 3 minus I. And then notice here that I distribute the negative into my parentheses. So negative times 2, -2, and negative is a positive I. And so we get a 1. Okay, so now we're going to simplify these type of problems. So we want to have -3 plus square root of -8 plus 5 minus square root of -56. So one of the things that you want to do first is deal with the negatives in the square root. So we're going to rewrite these problems so that it looks something like this, where we're going to have, well, first I dropped the parentheses. That's what happened here. But now for my negatives, isn't it true that -8 is the same as -1 times 8? And -56 is the same as -1 times 56. Now, we know that I squared is equal to -1. So we're going to replace those -1s by I squared. So -1 by I squared. Now, why is this important? Well, let me go back really quick. So we can also add -3 plus 5 gives me a +2. And now the square root of, let me just write this here. So whenever you have the square root of I squared times another number, if you're multiplying two things, then that's the same as the square root of I squared times the square root of 8. Okay, so the I squared and the square root, that becomes 1. Sometimes people say it cancels, but it becomes 1. And so we end up with I, square root of 8. Okay, so that is how we got to this point here. So just to save us time, we're not writing it out all the time. So I have an I squared here. So I know that's going to become I. It's going to come out as an I. And then I have 56. Now, if you want to add radicals, then the radicands, which is the numbers inside, have to be the same. If they're the same, then we just add the numbers in front. So 1 plus 1 is 2 square root of 8. If they're different, like square root of 8 plus square root of b, then we cannot add these two radicals because the radicands, which are the inside, are not the same. Okay, so now that we reviewed that, I have 2 plus I square root of 8 minus I square root of 56. The radicands are 8 and 56. The way they're written, I cannot do anything with them. So I'm going to try to simplify them because we want them in simplest form, right? So 8 can be written as 4 times 2. And then 56, we can try to use, well, let me just continue and then I'll tell you something in a second. So 56, we have 4 times 14. Now the square root of 4 comes out as a 2, and don't forget your I. This 2 cannot come out, so it stays inside. And then we have this 4 would come out as a 2. Okay, so now we have 2 plus 2i square root of 2 minus 2i square root of 14. Can I add the square root of 2 with the square root of 14? And we can't because they're different. Okay. However, notice that we want to write in standard form. So that means that your answer has to look like this: A plus B times I. Okay, so real plus imaginary. So right now we have 3 terms, so it doesn't look like this one here. But notice that they both have an I in common. So we can factor out an I. And so now we have 2 plus I, parentheses, 2 square root of 2 minus 2 square root of 14. And so now it looks a little bit better. And let me go back. So you can leave your answer like that, but to make it look a little bit better, we can say 2 plus, and then put this here. It doesn't really matter, but let me just write it out on this side. Okay, so now we have A plus B, I. So this is your B part, and that's your A. Let's try another one. So if we multiply, we are trying to multiply these. So we just multiply just the same as if we had an X. Okay, so we're going to go ahead and multiply. 1 times 8 is 8. And let me just do this. So 1 times 8 is 8. And 1 times negative 7 is negative 7i. 1 times 8 is 8i. And I times negative 7, I is negative 7i squared. So if we simplify, we're going to end up with 8. Negative 7i plus 8i is I. And then we know that I squared is equal to negative 1. So anywhere I see an I squared, I'm going to put negative 1. And if we simplify some more, negative 7 times negative 1 is positive 7, plus 8 is 15. I want to check to make sure it's in standard form. It is. So my answer is 15 plus I. Okay, let's try this one. 17i times 1 is 17i. 17i minus or times negative 7i is negative 119i squared. We know that I squared is negative 1. And so if we simplify, we end up with 17i plus 119. Is this in standard form? So 119 plus 79. And so that would be our answer. And now we're going to write the quotient in standard form. So when you're writing the quotient in standard form, we want to go from this, and we want to rewrite it again as A plus BI. Okay, so in order to do that, we're going to need to find something called the conjugate. And the conjugate is going to be the opposite sign of what we have here. So you keep the same real part, the same imaginary part, but you change the sign from negative to positive. Then we're going to multiply the conjugate, or multiply the conjugate by the numerator and denominator. So that's going to look like this. And we can do this because 5 plus 6i divided by 5 plus 6i, that's equal to 1. So essentially, we're just multiplying this by 1. But we're going to make it look different. And we can do that because we're not changing the problem, we're just rewriting it. So if we multiply, now we're going to have 3 times 5, or 3 times all of this, which is 3 times 5 plus 6i. And then this 5 minus 6i times 5 plus 6i. So if we simplify, 3 times 5 is 15. 3 times 6i is 18i. And then here there's a shortcut, but we'll talk about it in a little bit. 5 times 5 is 25. 5 times 6i is 30i. Negative 6i times 5 is negative 30i. And negative 6i times 6i is negative 36i squared. If you have conjugates, Notice what happens to the middle terms here. 30i minus 30i will become 0. And so we end up with 15 plus 18i and 25 minus 36i squared. We know that I squared is -1, so we plug in -1. We know that I squared is -1, so we plug in -1 and keep simplifying. So now we have 25 plus 36, which is 61. This still doesn't look like standard form, so I can divide 61, divide both terms. So 15 divided by 61 plus 18 divided by 61. And we get 18 divided by 61i. And so that would be our answer. But let me just highlight here for us, if you have conjugates, yes, we can multiply the same way we did here. But if you notice, these middle terms are always going to be 0. So one of the things you can do if you have conjugates is you just square this one and you square your b. So you take a squared and b squared. So you end up with 25 plus the 36. Okay. So the last one here, I think it's, well, we might have 2 more. But we want to simplify this, write in standard form. So again, you want to deal with these negative first. So negative, we can write it as -1 times 75, -1 times 12. And then the -1, we can replace with I squared. So that's what we did here. And now we want to simplify a little bit more. So I squared comes out as I for both of these terms. And now I cannot add 75 and I cannot add the 12 since they're different. So we want to simplify. So 75, I can write it as 25 times 3. And so that's going to give me, the 25 is perfect. It'll come out as 5. And then for 12, I can write it as 4 times 3. And the 4 is perfect, so it'll come out as 2. And so now we'll have 5i square root of 3 plus 2i square root of 3. Notice now they both have the same radicants of 3. So we can add the coefficients here. So 5i plus 2i will be 7i square root of 3. So in standard form, we would have 0 plus 7i square root of 3. Okay, and then the last thing we're going to talk about is solving this quadratic equation. Okay, so again, you do have different methods, right? So you can try to use factoring and all the other ones that we were trying. But in this example, if you try to factoring, what happens? Can we factor? So we try to factor, right? You end up with 2 of these, x and x. And if you try to use 2 and 1, then what happens? The 2 and the 1 will never give you a 2 here. So this does not factor. So one of the things I tell my students is, I personally like to factor because I feel like it's quicker, but not everything factors. So if you're trying to factor this, give yourself a minute. If you can't factor it, then we want to use something else. This example, we're going to use the quadratic formula. And so we have, we're going to identify our a. So a is the number in front of x squared, which is 1. B is the number in front of x, which is -2, and c is 2. So we're going to plug these numbers into the quadratic formula. So we have -b, which is -2, plus or minus b squared, which is -2 squared, minus 4 times a times c. So we end up with -4 times 1 times 2. Simplify. Negative is positive. -2 squared is +4 minus 8 divided by 2. 4 minus 8 is negative 4. And so notice now that this is a negative in the parentheses. So that actually tells us a couple of things about our graph, right? So our graph will never cross the x-axis. So if you were to graph this, it's not going to cross this x-axis. Okay, but if we simplify, negative 4, the square root of, well, we can write negative 1 times 4 so that we can take care of that negative. The negative 1 is the same as I squared, which the square root of I squared would be I. So now the square root of 4 is just 2. And then we can simplify further. 2 divided by 2 is 1, and 2 divided by 2 is 1. So here I broke it down, divided by 2. So now we have 1 plus or minus I. So here you should have 2 solutions, right? 2 zeros, and it just happens that our zeros are imaginary. So they're not real solutions, but they are imaginary. So 1 0 is x plus I, and the other is 1 minus I. Okay, and so that would be our 2 zeros. Oh, I had it on the next page. Okay, and so the next sections are going to be really looking at the zeros. And so you want to remember synthetic division is a tool that you can use to help us find those zeros. And so I believe that's all we have for today. And I think we don't have a happy hour. Wait, hold on. We don't have a happy math hour next week, but I will pass it over and they'll tell us when our next happy math hour will be. And so thank you for joining us today.
Hello, thank you so much, Ms. Hooper, for your wonderful presentation. We do want to remind you all about the previously recorded sessions, which are available on a YouTube playlist. This session will also be available on that playlist later today. Also linked was a short survey to help us improve our TVE sessions. Please take a few minutes to fill out that survey, and before you all leave, I want to share the TVE sessions that we will have next. At 1 p.m. in this room, we will have a presentation from the Veterans Resource Center, and we will be back with Happy Math Hour next week at 11 a.m., where Math 1314 will cover finding zeros of polynomial functions, and Math 1324 will cover simple compound interest annuities. Our 1 p.m. session next week will be a presentation with the Paso Cesar Chavez and Oral History Project. Thank you all for coming in today. We hope you all have a lovely weekend. If you have any questions, feel free to use the chat box or your mic. We hope to see everyone again for Happy Math Hour.